My name is Patrice Pedrago. Our team members are
Jonathan Barstead,
Andrew Quavy,
Alex Quach,
Sandeep Singh Rai,
and Connor Wilson.
We are here to talk about the non-contact interaction with common items project that we develop with the guidance of our sponsors and advisors. Our team was tasked to develop technology that would mitigate the propagation of COVID-19 through the contact with common objects. After examining several areas where the technology is needed, the team decided to develop two separate solutions: an elevator panel with a non-contact interaction user interface, and a desk system which detects and constantly displays its status of cleanness to the user. Other optional technologies are also represented on the sketch here.
We will first be going over the touchless elevator panel. Our touchless elevator panel replaces typical elevator buttons with infrared brake beam sensors, allowing for touch-free elevator operation. Each sensor is located towards the front of a depressed cylinder, taking the place of a typical elevator button. A backup physical button is also available at the back of each depressed cylinder, allowing for physical operation of the elevator in the event of sensor failure. These brake beam sensors produce a high output signal when sight between emitter and receiver is broken. This output is exactly what we want, as the typical elevator button also produces a high output when pressed. Once these sensors or backup buttons are activated, the output signal is then sent to the elevator control system. For prototyping purposes, our team decided to implement an Arduino microcontroller to work as a partial control system, which is responsible for LED activation based on corresponding sensor activation.
This is a video demonstration of the elevator prototype panel in action. An LED inside each tube turns red to indicate activation. One can hold their finger in the tube to simulate the holding of a button. We have also wired up buttons at the back of the tube as a real panel would have, in case of sensor failure. We tested the prototype panel using a variety of objects to trigger the brake beam sensor. Except for objects too thin to block the infrared beam completely, such as a key angled parallel to the beam, we found no reliability issues.
We will now be presenting the idea for Smart Desk. This is the first of two solutions we developed to reduce contact with common objects. It is not only one that can be useful in schools, but also expand availability to other establishments that have tables, desks, or countertops. The concept behind the Smart Desk is to not limit the usage of them while still abiding by the healthcare COVID guidelines. Last semester, the idea was to implement distance sensors on every desk in order to gauge individuals' approaching distance to the desk. One of the four following statuses are assigned to each desk in a room: clean, in use, paused, or dirty. When a person is very close to a desk for an extended amount of time, it is assumed that the desk is now in use. When the same person walks away from the desk and plans on returning back, the status changes from in use to pause, and once he leaves the desk, it changes to dirty. Next slide shows the video demonstration of above concept. As we can find in the video, work area is in clean state. Alex at that point sits on the chair, and that triggers the LED to change the status to blue, demonstrating being used. At that point, Alex moves his hand closer to sensor to change it to pause state. To move it back to in-use state, Alex presses the button on the keyboard, and once he leaves the work area, desk goes to dirty state. And as soon as someone cleans the area, desk changes back to clean state.
The previous prototype using the distance sensor works but has its limitations and inefficiencies. Therefore, this semester, our goal was to transition to computer vision to make the system more effective in monitoring multiple workstations. Our main objective of the system are the successful detection of people using computer vision, ability to set up desk locations, bi-directional communication between Jetson Nano and Raspberry Pi devices, and the creation of a desk unit that houses the Raspberry Pi and the brake beam sensors to create a sleek, functional system.
In this video, we demonstrate the on-desk unit being manually toggled by the sensor from clean to in use to dirty and back to clean. This operation occurs only when there is no established connection between desk units and the computer vision system. This is the desk location setup program. Once started, the first frame of the camera feed is saved as a picture and is then opened. Clicking on each desk saves the XY coordinates of the image to a file, where these coordinates can be accessed by the desk monitoring system.
The units 1, 2, and 3 correspond respectively to the desk in the front row of the lab. First, Andrew walks up to desk 1. The system will change to blue, signaling an in-use status. If he needs to use the restroom and come back, he can pause the system with a brake beam sensor. In this case, I am triggering them for each desk. Sandeep then uses desk 2, and John will use desk 3 to show the system functioning with multiple units simultaneously. They will leave once the system is in use. Andrew comes back to desk 1. Desk 1 will return to an in-use status. As that happens, he will leave. Once a user leaves, the desk unit turns red, signaling a dirty status. It can be manually reset once someone comes and cleans it and triggers the brake beam sensor on each desk unit. Though we produced great results with a single webcam, to further increase accuracy, we implemented a depth camera. Firstly, desk positions are manually selected in an updated setup program capable of obtaining X, Y, and Z coordinates. Desk 1 is the bottom left, and desk 2 is the top right. Once desk positions are set, the main program starts. To begin, I move to desk 1. Once the desk turns to in use, that desk is paused. I am then free to walk away without changing the desk's status to dirty. Next, Connor walks to desk 2. As a result, the status changes to in use. Connor then walks away and stands behind desk 1 to demonstrate that desk 1 cannot be accidentally unpaused by someone standing behind the desk. Then I return to desk 1 and the status changes back to its in use state. Finally, I walk away, and when both desks are dirty, they are manually reset back to clean.
This is the evaluation of each function in this system. Most of the functions in this system are software-based and they work as intended to accomplish the desired task at a basic level. Testing results with a depth camera resulted in more accurate desk statuses due to 3 coordinates defining a position instead of 2. We would like to thank our sponsors and our campus faculty for all their help throughout this project.